Synaptic Communication by Cassandra Arrington. In synaptic communication, the first step starts in the neuron. In the neuron, there is an axon. An axon is a thread-like part of a nerve cell that has dendrites, soma or body, nucleus, and axon terminals. This is how the signals travel throughout the neuron. As soon as a signal hits the axon hillock, an action potential begins. In an action potential, the threshold is the intensity it must exceed for a reaction to occur. During this action potential, it goes through depolarization and repolarization. Depolarization is when the sodium ion, Na, rushes into the cell's membrane, making it more positive. So you can see on this graph, this is where threshold starts. And then, as sodium ions rush into the cell's membrane, it becomes more positive, reaches positive 30. Repolarization comes to play when the potassium channel opens. Potassium goes out of the cell's membrane. The potassium channel closes slowly, which makes the cell extremely negative. So as the sodium channel closes, potassium will open, making it more negative, because it closes so slow. And oops, it got extremely negative. The term for being extremely negative is called hyperpolarization. That's what this is called. And for it to go back to its normal resting potential, it has to go through the sodium-potassium pump. This all happens throughout the length of the axon, and now we're going to go to the axon terminals. The signal has gone through the dendrites and has hit the axon hillock. It's now going through the nodes of Ron-VA. It's going through here. This is where the action potential begins. Boom, goes through, and now we're going to go and explain what happens when the action hits an axon terminal and where it goes. So right here, you can see the presynaptic neuron, synaptic cleft, and postsynaptic neuron. What do they mean? Well, I'm going to explain that. The process in which the neuron receives information is called the synapse. As the neurotransmitters travel down the axon and enters through the presynaptic neuron, it begins exocytosis. Two classes of neurotransmitters, sodium and calcium, go into the cell, causing depolarization, which promotes action potentials not only in the axon terminal, but in the action potential itself as it goes down the length of the axon. For exocytosis to occur, calcium ions need to be inside the axon inside the axon terminal. The calcium enters the axon terminal through the L-type voltage-gated calcium ion channel, which regulates calcium into excitable cells. So whoa, a lot of information. Well, here you have your presynaptic neuron. These are your neurotransmitters, and these are calcium ions outside of the presynaptic neuron. Let me zoom in, sorry. Okay, so these are calcium ions outside. For them to come into the presynaptic neuron, here are your L-type voltage-gated calcium ion channels. This is how they get through and come in the presynaptic neuron. And they're neurotransmitters. So that's basically what I just explained to you. Once the neurotransmitters are outside of the axon terminal, they go to the synaptic cleft, which is a space between the axon terminal and the other neuron or muscle. So after they've reached here, the vesicles and neurotransmitters, they release the neurotransmitters out of the vesicles, calcium ions, and these little neurotransmitters will go out and enter the synaptic cleft. That is what this space is called. From there, the neurotransmitter will attach itself to a neurotransmitter receptor and are now in postsynaptic neuron. In the postsynaptic neuron, there is a channel called the ligand-gated ion channel, or the ionotropic receptor, which is allowing the sodium ions into the postsynaptic neuron. Now that the neurotransmitters are through this channel, it will either reach another neuron or go into muscles, causing action potentials to help the body react. So after the neurotransmitters go through the synaptic cleft, they will hit these and go through these ligand-gated ion channels, or ionotropic receptors, and go in a postsynaptic neuron, which will then reach a nerve or another muscle. And that is how synaptic communication works.